So greetings of the day students. Welcome to the next session of Theory of Computation. Today's topic is finite automata, transition diagram, transition table and DFA. So objectives, after going through this topic, you should be able to know about the abstract machine, understand the concept of finite automata with its characteristics, draw transition diagram and transition table, and know the categories of finite automata, that is DFA and NDFA. Then you should be able to learn the technical definition of DFA. So these are the objectives of today's lecture. Let's begin with the topic. So first of all, automata theory. So automata theory is study of abstract machines. Now, what is an abstract machine? Abstract machines are those machines which are not implemented but represented using some formal notations. So, for example, you have seen the switches at your houses, right? Electricity switch. A switch will go from off to on state when we apply pressure on it. When we apply pressure P, we will move from state Q0 to Q1. Basically, we have, first of all, initially, when you are not in your room, your switch is in off state. When you apply a pressure, for example, when you push a switch, it will be moved from off state to on state. Let's suppose this push is pressure P, right? So here the state changes from off to on. Let's suppose off represents Q0 and on represents Q1. Again, when you apply some pressure, let's suppose this time the pressure is small r. Again, when you are in on position and when you apply a sufficient pressure R, again it will move from Q1 to Q0. So this is a simple example for abstract machine, right? So push is an action, or you can say that a pressure here. On and off represents state. So definition of automata. So an automata is defined as a system where energy, material and information are transformed, transmitted and used for performing some functions without direct participation of a man. So here you can take any example. You are using automatic photo printing machine. You are using electric ovens at your home. You are using washing machines, right? So all these examples listed under the category of automata. So let's take an example of electric oven in which you are going to cook rice. So here, for example, we have to cook rice and the entire rice will take 20 minutes to cook, right? So initially, we will put uncooked rice in the oven, right? After some time, let's suppose after 10 minutes, these rice will be changed their state from uncooked to cooked. So after 10 minutes, right? So it will be semi-cooked rice now. So after 20 minutes, you will get fully cooked rice from your oven. So here what you have to do, you simply start the oven, put your rice and give the input. That's it. After that, the overall work will be performed by the oven itself, right? So that is why this is called without the direct participation of man. I hope the concept is clear. I'm repeating again. An automata is defined as a system where energy, material, and information are transformed, transmitted, and used for performing some function without the direct participation of a man, right? So you are just giving the input, that's it. So this is one of the example of automata, that is your electric oven. One more example, let's suppose now you have to take one printout. You have to take one printout of the soft copy, right? So first of all, you are opening up your document, for example, dot ppt or dot doc, right? Now, after opening up your document, you have to press Control plus P. After that, the entire job will be done by the printing machine. Am I clear?
Yes, sir.
Right? So again, here is without the direct involvement of human, right? So here you can see the diagram for model of direct automata, right? So here we have some input. Let's suppose this is your system. We have some inputs which will be written with I1, I2, so on up to IK, right? And all your inputs will be processed. Let's suppose that processing is called states, Q naught, Q1, and so on up to Qn, right? So here the input will be processed. So those processing is called state changes. Then we have, if you have provided some input, definitely you will get some output for it. Let's suppose for I1 you have the output O1, and for I2 you have the output O2, and for IK you have the output OK, right? It means for every input, that input will be processed in multiple forms and you will get the corresponding output as well. So this is the simplest definition for automata. Next we have its characteristics. So we have 5 characteristics for automata. The very first one is input, the second one is output, the third one is states, then we have state relation, and last but not the least we have output relation. So the very first characteristic is input. If you don't give any input to the system, you will not get any sort of output, right? So very important first characteristic for automata is input. So here at each of the discrete instance of time T1, T2 and so on, input values I1, I2 and so on will be there. So each of which can take a finite number of fixed values from input alphabet sigma are applied to the input side of model. So this is your input side of the model. Next we have output. So here O1, O2 are the outputs of the model, each of which can take a fixed number of input values. So these are the outputs corresponding to input. These are the output. Next we have state. So at any instance of time, the automata can be in one of these states, that is Q0, Q1, so on up to Qn. Next, fourth characteristic is state relation. So what does this mean? State relation means the next state of automata at any instance of time is determined by the present state and the present input. It means that we have this state which will be written with capital Q. So it is dependent upon two things. The one is called I, that is your input, and the another one is called present state, again which will be written with Q, and the another one is present input. So this is your next state. This is your current or present input. This is your current state, right? So this is your state relation. Similarly, for output relation, the output is related to either state only or both to state and input as well. Okay, right? So either the output will be dependent upon, the output is dependent upon state only. Fifth characteristic says that the output is dependent upon state only, which will be written with Q, or your output may be dependent upon state as well as on the input, right? So these are the 5 different characteristics which will be used for automata. So note, an automata in which the output depends on the state of the machine is called Moore machine. So we have 2 different categories of machine over here. The one is called Moore and the another one is called Mealy. So first of all, we'll make you clear about the Moore machine. In case of Moore machine, your output is dependent upon the state only. In Moore machine, the output is depends upon state only, right? And in case of Mealy means generally whenever you reach college, 2 people meet hands with each other. Mealy, right? So Mealy machine means 2 things. Here, your output is dependent upon state and on input as well. State and input as well. I hope both the machines are clear to you, right? We will elaborate this topic in the later on section. So next definition is for transition diagram, right? So a transition diagram or state transition diagram is a directed labeled graph which can be constructed as follows. So first of all, you should know some basic terms, right? So which can be constructed as follows. The first condition says that there is a node for each state in Q which is represented by the circle. So here this circle represents the node. Suppose this is your Q node, right? So there is a directed edge from node Q. So this is your node Q to node P. So let's suppose this is second node P, right? This is your node Q and this is your node P. So each node will be represented with the help of circle. So they are your state. These are your states. Again, this is your state, right? Or you can say it as node, node, right? So it says that labeled A if Q comma A is equal to P. It means here Q approaches to P by processing small a. So here A is acting as a input. A is acting as a input. So next condition says that in the start state, there is an arrow with no source. It means there is an arrow with no source. It means there is no input over this arrow, right? So this state will be acting as your initial state. A circle, incoming arrow towards the circle, it is your initial state. Next we have your final state will be represented with the help of double concentric circles. So here P will be acting as your final state. I hope the concept is clear. Just wait. So last condition says that accepting state or final states are indicating by double circles, right? So this P will be acting as your final state. So you can see one transition diagram. So this is your transition diagram in which A is your input, Q and P are two states. Here Q is acting as a initial state and P is acting as a final state. Why Q is called initial? Because it is represented with incoming arrow towards the circle. And why P is called final state? Because it is having double circle. So this is a definition for transition diagram. So you can see this diagram. This is a diagram for transition diagram, right? So here we have the initial state Q naught and we have the final state Q2, right? And we have two inputs 0 and 1. This complete diagram represents transition diagram, right? So let's understand one more definition which is called transition table. So how to make a table from the given diagram? Let's proceed. So first of all, the transition table is basically a tabular representation of a transition function. It takes two arguments, a state and a symbol, and returns a next state, right? So here a transition table is represented by following things. The first thing says that the columns correspond to input symbols, right? So first of all, the columns. So here, let's suppose if I have to make the table for the given diagram, which is shown in front of you in the PPT. So first of all, let's suppose this is the input 0 and this is the input 1, right? And we have three states. This will be written with states slash sigma, state slash input, right? So we have three states. Q naught, it is your initial state. Q1 and Q2 will be acting as your final state. Remember students, in case of transition table, you have to represent the initial state with the arrow only, and you have to represent the final state with single circle instead of double circles in case of transition diagram, right? So second condition says that the rows correspond to states. So here you need to write the state, right? So entries correspond to next state. So here you will get next state, right? So let's check in the later on section. The start state is denoted, that is your initial state, by an arrow with no source. So this is your initial state, that is your start state. This is your initial state, right? And this is your final state. Final state is also called accepting state or accept state, so which is denoted by single circle. So let's make the table for the given diagram which is shown in front of you. So here Q naught upon the processing of 0. So Q naught upon the processing of 0, it goes to Q1. So here Q1 is your next state, right? So Q naught, how you will represent it? So you can write it as delta Q naught comma 0. It will lead you Q1, right? So Q naught upon the processing of 0, it will take you to Q1. Similarly, so Q naught upon the processing of 0, it will take you to Q1. Similarly, Q naught upon the processing of 1, it will take you to Q2. So here you will write Q2. Next, Q1 upon the processing of 0, you will get Q naught. Next, you have Q1 upon the processing of 1, it will take you to Q2. Next, last state is Q naught upon the processing of 0 and 1, it is going to itself. So this thing is called iteration, that is loop. So we have just drawn the table from the given diagram, right? So you can see the transition table corresponding to this diagram. So you can see the explanation which I have just told you earlier, right? So in the below table, the first column indicates all the current states. So these are your current states, or you can say that present state, right? This is your column number 1. This is your column number 2. And this is your column number 3. Similarly, we have row 1, row 2, and row 3, right? So the first row of the transient table can be read as when the current state is Q naught, this is your current state. On input 0, this is input 0, the next state will be Q1, right? And on input 1, the next state will be Q2. I hope the concept is clear to you. Similarly, in the second row and in the third row. And the arrow marked to Q naught indicates that it is the start state, and circle marked to Q2 indicates that it is a final state as well. Am I clear?
Yes, sir.
So moving towards the first pole. So I am showing you first pole, right? So you have 2 minutes to answer these two questions. Read the question very carefully and then answer it. First question is based on yesterday's topic, that is basics of automata.
Sir,
Yes,
sir, I didn't get the poll.
you didn't get the poll.
Yes, sir.
Better relaunch it.
Oh, okay, sir.
Anyone else has facing issues? Hurry up, students. You have only 25 seconds. Hurry up. Answer fast. Last 5 seconds. Only 24 students have given the answers. So thank you very much. So first question is basics of automata consists of. So the answer is all of the above, right? So yesterday we have learned all the concepts, that is alphabet, strings, languages, problem and grammar. So second question is this sigma symbol is used to denote the alphabet. The second option is the right one. Showing you the results. So moving towards next topic, that is technical definition of DFA. Earlier we did the simple definition of finite automata. Now we have two types of FA. We have two different types of FA. The first is called DFA. FA has been bifurcated into two parts. The one is called DFA. The another one is called NDFA. You can have a look on the whiteboard. The board is visible to everyone. The board is visible to
Yes.
everyone.
Sir, it is half visible. Yes.
Okay. So here in the technical definition of DFA, we have five tuples. We have five tuples. The first tuple is called Q. The second tuple is called sigma. The next is called delta. Then we have Q naught and F. So these are the five tuples which are available in DFA, right? So here capital Q denotes finite set of states, right? So capital Q is represented with Q naught, Q1 and so on up to Qn. These are your states which will be written with Q naught, Q1, Q2 and so on up to Qn. Next we have sigma. Next we have sigma. So sigma is a finite set of input symbols, or you can say that alphabet. I told this thing in yesterday's lecture. That is your set of input alphabet. Next thing we have delta. So delta is what? It is your transition function. Transition function which will let you know about previous state and your final state, next state, sorry, which is a mapping between, that is, it will let you know about Q into sigma goes to Q. This represents current state, current input. This is your new state, or you can say that present state, present input, new state, or next state.
Excuse me. Hello. Hello.
So let's take an example. So here, this is your 5 tuples, right? So 5 tuples are represented with M, right? So Q, sigma, Q naught, F, comma, delta. So here Q naught is the initial state and capital F is the final state, right? So I am writing each tuple one by one. So first of all, we have a Q. So Q consists of 3 states, Q naught, Q1 and Q2. Next we have input alphabet. So we have 2 input alphabet, 0, 1. Next we have initial state, which is your Q naught. Next we have final state. Here Q2 is acting as your final state. It means Q2 will be represented with double circle, right? Next we have delta. So we have to define the delta. So here I am defining delta, that is, so Q naught is acting as your initial state, Q1 and Q2 are your intermediate state. Here this Q2 is your final state, right? So you can see that Q naught upon the processing of 0, Q naught upon the processing of 0, it is going to Q1, right? Q1, and Q naught upon the processing of 1, it is going to itself. So that is the reason why I have drawn one loop over Q naught, right? So I am drawing the table one by one. Next we have so Q1 upon the processing of 0. So Q1 upon the processing of 0, it is going to Q2. So upon the processing of 0, it is going to Q2. And upon 1, upon the processing of 1, it is going to Q1. So Q1 upon the processing of 1, it is going to Q1 next. So Q2 is your final state. That is why I have drawn one single circle upon Q2, right? So Q2 upon the processing of 0, Q2 upon the processing of 0, it is going to itself. So a loop will be there. Next we have Q2 upon the processing of 1, it is going to Q naught, right? So this is your DFA. The DFA means for every input. So here you can see that for every 0 and for every 1, you will get single state output. Again, for 1, you will get a single state output. This is called your DFA. right? So here you will get single output for 0, that is Q1, Q2 and Q3. Single output. This is called your DFA. If you have multiple outputs will be written over there, that thing is called NDFA. We'll discuss in the later on section. I hope the DFA concept is clear to everyone. Next we have application areas. So application areas of finite automata. So first application area is vending machine. The second one is traffic lights. Next we have video games, text parsing, regular expression matching, or you can say that string matching, CPU controllers, protocol analysis, natural language processing, speech recognition, lexical analysis phase of a compiler. Last but not the least, that is design of digital circuit. So this is all about FA, transient diagram, transient table, and applications, right? So next topic is NDFA. NDFA stands for non-deterministic finite automata. So again, objective. So after going through this topic, you should be able to define. The first one is acceptability of string by finite automata. Understand the concept of NDFA. Then we will compare the two FAs, that is DFA and NDFA, and then we will learn the conversion of NDFA to DFA, right? So first of all, acceptability of a string by finite automata. A transition system accepts a string W if there exists a path which originates from some initial state, goes along the across and terminates at some final state, right? The second thing says that if the path value obtained by concatenation of all the edge labels is equal to n, right? So here the string is represented with W, right? What you have to do, let's suppose the value of W is equals to 0, 1, 0, 1, 1, 0. So this is the string which is given to you. Now you have to check that whether this string is accepted by finite automata or not. First of all, its definition says that you have to start with the initial state after the processing of entire string. That is, the entire string is 1, 0, 1, 0, 1, 1, 0. After the processing of entire string, if you will end up at the final state, then the string is accepted by the given automata. If somehow you don't reach at the final state, you will reach at some intermediate state, then the string is not accepted, right? So string W is accepted by a finite automata. M is, let's suppose M is a finite automata, which will be represented with 5 tuples q, sigma, delta, q naught, comma f. So if delta q naught, comma w, here w is your string, right, is equals to f. F means final state, right? So where q naught is initial or start state and f is the final state. So for every input symbol of string, it takes one transition and starts with initial state and reaches final state by reading the complete string. So let's move toward the practical aspect, practical example. So here a table is given to you, right? And the string, the value of the string is so the value of W is equals to 110101. So W is equals to 110101. So let's check whether this string is accepted by FA or not, right? So your FA is represented with the help of table, which is shown in front of you in the PPT, right? So here Q naught is acting as initial state and it is acting as final state as well. It is written over here, right? So Q naught is acting as initial as well as final state, right? So let's check. So first symbol is, you have always start with the initial state, then process one symbol at a time, right? So here the first symbol is 1. So Q naught upon the processing of 1, check in table. So Q naught upon the processing of 1, it is going to Q1. It is going to Q1, right? Next input is again this 1. So Q1 upon the processing of next one. Q1 upon the processing of this one. So this is your Q1. Q1 upon the processing of this one, it is going to Q naught. So here you will write Q naught. Next input is this 0. So Q naught upon the processing of 0. Q naught upon the processing of 0, it is going to Q2. Right? Next input is this 1. So Q2 upon the processing of 1, it is going to Q3. Next we have the next input is this 0. So Q3 upon the processing of 0. Q3 upon the processing of 0, it is going to Q1. And the last input is 1. You have to represent it in single line because here we have less space. That is why I have molded to downward direction, right? So last input is Q1 upon the processing of 1. So here you can see that in table Q1 upon the processing of 1, it is taking you to Q naught. So here Q naught, we have just started from the Q naught, which is your initial state, and we are left with Q naught. Again, it is your final state. This means that this particular string is accepted by finite automata. The string is accepted by the given FA. I hope the concept is clear to you. The string is accepted by given FA because we have started from the initial state and we are end up at the final state. Remember one thing, the final state may be same or it may be different. So here you can see that Q naught is the initial state and Q naught is the final state. It may be the case where Q2 or Q3 will be acting as your final state, right? I hope the concept is clear to everyone. Acceptability of string by finite automata. Am I clear? So let's move towards next poll. So I am launching second poll. Start answering. Again, you have 2 minutes. So thank you very much for your answers. Only few students have attempted the polls. So first question is, in transition diagram, initial and final states are shown as, in diagram, the initial state will be written with arrow and final with double circle. The second option is the correct one in question number 1, right? And in case of second question, in transition table, initial and final states are shown as, so here the initial with arrow and final with the single circle. The third option is the correct one, right? Sharing you the results. So one more poll is there. Kindly students, all the students are requested to attempt these questions, right? Otherwise you will be marked absent. Whosoever will not attempt these questions. Next, last poll for today. 2 minutes to solve it. Last 30 seconds. Hurry up. Thank you. So first question is DFA is dash tuples. So the right answer is 5. Which symbol is used for transition function? That is this delta. Second option. Sharing you results. So next topic is NDFA, non-deterministic finite automata. So here again, just like DFA, NDFA is also having 5 tuples. Same tuples will be there, but with a little difference, right? Just like DFA, NDFA is having same 5 tuples: Q, sigma, delta, Q naught, and F. Here Q is your finite non-empty set of states. Sigma, finite non-empty set of symbols called alphabet. Delta is your transition function. In this you will get a change, right? And Q naught is initial state, F is the final state, right? In case of DFA, your delta is Q into sigma goes to Q, right? But in case of NDFA, this delta becomes Q into sigma goes to 2 raised to power Q. This is the difference between DFA and NDFA. That is, for every input you have a single output. For every, this symbol is used for every input, single state output is there, right? But in this case, for every input, multiple state outputs are there. This is a difference, right? In case of NDFA, for this we have single input, single output. But for this you have single input, multiple state output, right? So let me show you this thing with the help of a diagram. So here you can see the example M. So here I have taken capital Q is equals to Q naught, Q1, Q2, Q3, Q4. A total 5 states are there. Next we have input 0, 1, Q naught, that is Q naught is acting as your initial state and Q4 is acting as your final state. Here delta, that is your transition function, is represented as, so let's make the diagram. So two inputs are there, 0, 1. The first, that is Q naught. So Q naught upon the processing of 0, it is going to Q4. So upon the processing of 0, it is going to Q4, and upon the processing of, here you can see that upon the processing of 1, it is going to multiple states, that is Q1 and Q2. That is why this is called NDFA, right? I hope the concept is clear to you. And upon Q1, it is going on no state. Similarly, upon Q2, it is going on no state. So here Q0 is acting as your initial state and Q4 is acting as your final state. Right? Am I clear about the concept of NDFA? Let me show you one more example on the blackboard. So what is the diagrammatic difference between DFA or NDFA? So let me show you. That is Q note upon the processing of 0, it is going to itself, and upon the processing of 1, it is going to Q2, right? So here you can see that Q note upon the processing of 0, it is going to single state. Q note upon the processing of 1, it is going to single state. That is Q1. This is your Q1. Similarly, Q note upon the processing of 0, it is going to itself a loop, and upon the processing of 1, it is going to single state. So this is your DFA, right? So what is NDFA? So here you can see that Q note upon the processing of 0, it is going to itself, and upon the processing of 0, it is going to next state. So you can see that upon single input, you have two outputs. Upon single input, the input is 0, but you are getting two outputs, that is Q note and Q1, right? Similarly, Q note upon the processing of 1, it is going to itself. So 0, 1. Although you can also show it as one more loop is there with 0, right? So if I have to draw the table for DFA, your table will look like 0, 1, initial state Q note, final state Q1 because of this double circle. So Q note upon the processing of 0, it is going to Q note. Q note upon the processing of 1, it is going to Q1. And Q1 upon the processing of 0 itself, and upon the processing of 1, it is going to. So you can see that here you are getting single output, single state output, right? But in case of NDFA, here Q note initial and Q1 final, 0 and 1 is input, right? So Q note upon the processing of 0, that is Q note comma Q1. So here you can see that you are getting multiple outputs, more than one output. That is why the delta is Q goes to sigma goes to 2 raised to power Q. Q into sigma goes to 2 raised to power Q. More than two state outputs are there. That is the reason this is called NDFA, non-deterministic finite automata. I hope the concept is clear to everyone.
Excuse me, sir.
Anji,
सर वो थोड़ा बोर्ड ना लिटिल बिट इज बीइंग कट सर, दिख नहीं रहा है थोड़ा बहुत.
let me complete it first, then we will be clearing doubts, right? So next we have the next concept is conversion of NDFA to DFA. The conversion of NDFA to DFA. So here you have small a and small b as your outputs. Small a and small b will be acting as your outputs. So let me draw it table on the blackboard. Then we will solve it. 0, 1. So here Q note, Q1, Q1, Q2, and Q3. So Q note upon the processing of A, Q note comma Q1. Then we have Q2 and Q3 dash. Next we have Q note 1, 3, Q note 1, 3, and Q2, right? So this is a table which is given to you. Here Q note is acting as initial state and Q3 is acting as your final state. So how to make it corresponding DFA? So this is your NDFA. Because why this is called NDFA? Because here you are getting multiple state outputs. Upon the processing of 0, Q note upon the processing of 0, you are getting two different outputs. The one is called Q note and the another one is called Q1. So let's make it corresponding DFA, right? So first of all, in DFA, always start with the first, always start with the initial state, that is your Q note. After that, forget about all the states, right? Always start with the initial state. So, and now you have to represent your states with square brackets, right? You have to represent your states with square brackets. So first of all, Q note upon the processing of 0. So Q note upon the processing of 0, it is going to Q note comma Q1. This is two different states, but this is your single state, that is Q note comma Q1. I hope the concept is clear, right? Next, Q note upon the processing of the 1, it is going to Q note. Now you have to write those states which have not been traversed even a single time, right? What you have to do, you have to write those states which have not been listed over here. So Q note have already been listed, but Q note comma Q1 no. So write Q note comma Q1 as a second state. So again, you need to check Q note upon the processing of 0. So Q note upon the processing of 0, it is going to Q note comma Q1. And Q1 upon the processing of 0, again you need to check Q1 also. So Q1 upon the processing of 0, it is going to Q2. So this thing is complete. Next, Q note upon the processing of 1, it is going to Q note, and Q1 upon the processing of 1. This Q1 upon the processing of 1, it is going to Q1. So I have written this, written this, written this, but these one state, this one state is not written. So take this state to left hand side, right? And you have to draw this table until or unless all the right hand states have been listed on first column single time, right? So by doing so, you can see that we will be left with this table, right? So I have, by doing so, you will be left with this table, entire table. So here you have to circle all the states which consists of Q3, right? Which consists of Q3. That is, you have to make one circle over this and one circle over this. Am I clear? Only to this side. That is Q0, comma Q1, Q2 and Q3 circle, because this is your final state, right? And these consists of Q3. Similarly, one more circle for Q0, comma Q1, comma Q3, right? Remaining table is same. So this is your conversion of NDFA to DFA, right? So this Q0, comma Q1 represents two different states, but whenever you will write 1, 2, 3 states with the help of square bracket, it will represent single state, right? I hope the concept is clear. After that, you will have to draw the transient diagram for this table, right? You have to draw the transient diagram for this table. Let me draw its diagram. So first state is, which is written in front of you, is Q note. So here Q note with square brackets. Don't forget to put the square bracket in front of your state, right? If you write Q note, comma Q1 without square bracket, this thing is wrong, because you can't write two states in single circle without writing square bracket. This thing is wrong, right? Always put a square bracket whenever you have more than one state. So Q note upon the processing of A, it will take you to, upon the processing of A, it will take you to Q1, comma Q note, comma Q1. The first entry, that is Q note, comma Q1. Second entry is Q note upon the processing of B, that is upon the processing of B, a loop will be there, right? Upon the processing of B, a loop will be there. Next, second row, Q note Q1, Q note Q1, upon the processing of A, it is going to, upon the processing of A, it will lead you to Q note Q1 and Q2, right? Q note Q1, Q2. Next, we have upon the processing of B, again a loop is there. Upon the processing of B, a loop will be there. So two rows have been completed. Moving towards the third row, Q note, Q1, Q2. It will take you to a new state. Upon the processing of A, you will get Q note, Q1, Q2, Q3. Again, this is your final state. So make one more circle to this state, right? So this is your final state. Next entry is Q note, Q1, Q2 upon the processing of B. Upon the processing of B, it will take you to the new state. Again, that state is will be acting as your final state Q1, sorry, Q note, Q1, Q3, right? So we have completed first three rows. row number 1, row number 2, row number 3, moving towards fourth row, that is this. So upon the processing of A and upon the processing of B, it is moving towards itself. So here a concept of self loop is there with A comma B, or you can also write it as A and one more loop with B. Both things are correct. You can write it as A comma B as well. Both are correct. Now last row, Q0, Q1, Q3. So upon the processing of A, it is going to this state, and upon the processing of B, again it is going to this state as well. So here you can write A comma B. So this is your DFA, transition diagram for DFA. I hope the concept is clear to you. So this is the second example. So this time you will be given with convert the given NFA to DFA. This diagram is given to you. So first of all, you have to construct a corresponding table because comparisons are easier in case of table, right? So first of all, convert this diagram into table. So here Q2 is acting as your final state. In some books, circle is replaced with star, right? So if you will get some star in front of any state, this means that that state is acting as your final state, right? So this is a corresponding solution, right? So the corresponding solution for this is this, the DFA, the transient table, and the transition diagram. The last portion is difference between DFA and NDFA. Right? So this is done from my side.